Hello friends, and welcome to this video. So here in this video we are going to discuss some basics of motion, and this will be mainly useful for NCERT 9th grade students. Okay, so let us understand some concepts of motion. Okay, so what we'll learn in this video, so maybe we'll learn some of these topics, so maybe up to, let us say, we learn here up to rate of motion. Okay, from rest and motion to rate of motion, we learn in this video. Graphical representation, this part we'll discuss in another video. Okay, so definitions and examples of rest and motion. Okay, so just look around yourself, you will see many different things, right? Like a house. Okay, there is a house, this is a house, this is a tree, this is a chair. So just ask this question to yourself. Are these things changing their positions with time? No, they are not changing their positions with time. They are always present at their same original position. So such a state of these bodies is known as rest. Okay, rest means they are not changing their positions with respect to time. Okay, all the objects here are at rest as do not change their positions with time. A body is said to be at rest if it does not change. Okay, does not change its position with time. Okay, like a tree, a house, a chair, a table, etc. Those things, they just remain stationary at their own positions. Okay, now let us check some other examples. Okay, motion. So when do you say that something or a body is in motion? A body is said to be in motion if it changes its position with time. Okay, the body changes its position with time, then it is said to be in motion. Like a flying bird, you can see, like a running man, this man is running. Like a rocket, this rocket just has been launched from its launch pad. Okay, so all these things, what will happen to them with time? They will keep changing their position. Suppose you observe this flying bird now. Okay, this flying bird, you observe it now, but after 5 seconds you will see that this bird is somewhere else. It is not at the position of its start, but it will have moved some distance after 5 seconds. Okay, similarly that is the case with this running man. Okay, with this rocket. So all these things that change their positions with time are said to be in motion. And in other words, motion is the state in which a body changes its position with time. Okay, so now there is another concept, interesting concept, which is known as relative motion. Okay, suppose you are moving in a train, you look through the window, okay, and see that the roadside trees are moving backward in a direction opposite to the train's motion. Although the trees are at rest, you will observe that you will observe their apparent motion. Okay, although the trees are at rest, you will observe their apparent motion. What is this thing? I'm going to discuss in a while. This apparent motion is known as also relative motion of the trees with respect to the actually moving train. Okay. Okay, so here there is a train. You can see the train is moving from left to right, represented by this red arrow. And suppose you are inside this train, okay, and you look outside, you see the trees outside, and maybe there is a hillock, whatever it is there. So the train is moving from left to right, but somebody like you who is inside this train will observe that these trees are moving backward, moving in an opposite direction, okay, in a direction which is opposite to the direction of motion of this train, okay. So actually what is going on here? The train is moving, okay? The train is moving. But are the trees moving? No, trees are not actually moving, okay? Trees don't move. They, like just now we have seen in an example that trees are at rest, okay? They cannot move. But since you are inside a moving train and you are moving, so the trees, it will seem to you that the trees are changing their position in a direction opposite to the direction of motion of the tree. Although they are originally at rest, the trees are originally at rest, but for you, you will see that they are moving backward, okay, backward with respect to you or with respect to the running tree. So such a state is known as such an apparent motion. So the the trees are said to have apparent motion. Okay, apparent motion means some motion which is not actual, but it seems to us that the motion is present. Okay, so those type of motion is known as apparent motion. And this phenomenon of motion of these trees with time, although they are not actually moving, is known as relative motion. Okay, I hope you have understood this. Similarly, if you are standing on a road and you are standing in front of a road, and one of your friends just drives his car or motorbike, so what will your friend see? Your friend will see that you are moving backward with respect to him. Okay, although you are standing, you are not moving, but for your friend who is in the car or in the bike will see that you are moving backward. Okay, so these are the examples of apparent or relative motion. Okay, so for your friend, he will see that you have apparent motion, and therefore there would be some relative motion between you and your friend. I hope this interesting concept has been clear to you. So with this, I'm moving to the next topic. So motion description. So the question here is, how do we describe motion? Okay. A reference point has to be assigned. Okay. In order to describe motion, we need a reference point. Suppose, so we need a reference point to describe a motion. Okay. Suppose, let us say that your school is 2 kilometers to the east of your house. Okay. That means you have to be in motion along east and reach your school after you have traveled for 2 kilometers. Okay, so here there are two buildings. You can see one is your house and one is the school. Suppose your house is the reference point. Okay, this reference point, and with respect to this reference point, we will describe the motion here. And this is the direction. Okay, to the right is east, to the left is west, upside is north, and downside it is south. Okay. Suppose you start from your house and you move towards east. Okay? After moving for walking or cycling or biking, whatever mode you choose to travel to your school. So after traveling for 2 kilometers, so you reach your school. Okay? This is your school. So your house is the reference point, and you move eastward for 2 kilometers and you reach your school. Okay. So that is how your house becomes the reference point or origin. So it can also be called as an origin. Okay. And your school is the destination. Okay. So where your school is located, if I ask you the question, your answer should be the school is located 2 kilometers to the east of your house. Okay. So this is that is how we can describe motion, and we can describe it in terms of a reference point or an origin. Okay, I hope you have understood this topic. And here we are going to discuss a interesting topic: motion along a straight line. Okay. And in the course of motion along a straight line, we'll also learn about two other important concepts. One is distance, and another concept will be displacement. Okay, let me change the color of the pen back to. Okay. One is distance, and the another concept that we'll learn is displacement. Okay, so let us consider an object which is moving on a straight path. Okay, a straight path. Suppose it starts from O. Okay, the object starts from the point O. Okay, this is the straight path. The blue line you see, this is the straight path. and it moves through point, and it moves to the point R. The object starts from O and moves to the point R through two other points P and Q. Okay, through two other points P and Q. The distance covered from O to R is 60 meters. Okay, O to R is 60 meters. If the object moves back to O, from R, the distance covered is 70 meters. Okay. Oh, sorry. It should have been 70. Sorry. It should have been 60 meters, not 70. 60 meters. Okay, I'm sorry for this mistake. So it should be 60 meters. So O to R, the distance is 60 meters, and again, if this object moves from O to R and travels back to the point O, so 60 plus 60, how much it would have moved? It would have moved 120 meters. I'm sorry, it's not 140 meters, but 120 meters. So 120 meters is nothing but 60 plus 60 is equal to 120 meters. Okay. Okay, now let us consider a situation here. The object moves from O to R. Okay, O to R. So O to R, the distance is, and O to R, and moves back to the point Q. Okay, the object moves from O to R and moves back to the point Q. So what is the total distance traveled by the object in this case? So O to R, it is 60 meters, and R to Q, it is 20 meters. Okay, so the total distance moved by the object is 80 meters. Okay, the object has moved 80 meters from O to R and R to Q. Okay. Okay, so that is the total distance. Now, let me ask you this question. What is the shortest distance traveled by the object between O to Q? Okay, shortest distance. The answer is, as you can see, it starts from O and it ends at Q. So the shortest distance is short. So the answer will be 40 meters. So 40 meters is the shortest distance that the object has moved between the points O and the point Q. Okay. So you have understood. So shortest distance does not mean that you have to go from O to R and R back to Q. Shortest distances doesn't matter how you reach the point Q from the point O, but it is just the shortest distance. Okay, doesn't matter how you reached it. Okay. Suppose, let me give a quick example here. Suppose you were initially here at this point A. Okay, at this this is point A. Then you move to point B, and finally you are at C. Okay. Suppose this is you move from A to B, and just turn left and reach C. Okay. Suppose A to B distance was 4 kilometers. B to C distance is 3 kilometers. Okay. So actually you have moved for 7 kilometers, 4 plus 3 to reach C. But is this the shortest distance between A and C? A to B, B to C, is this the shortest distance? No. The shortest distance is this one. This distance is the shortest distance between your initial position and final position. So how much would that distance be? According to Pythagoras principle, that distance would be 5 kilometers. Okay. So not necessarily shortest distance should be how much distance you have covered. So what is the shortest path between your initial position and final position? Okay. So here, what is the shortest path between the points O and Q? The shortest distance is simply 40 meters. Okay, that is the shortest distance between these 2 points is 40 meters. And this is something called as the displacement. What is the displacement of the object? The displacement of the object is simply 40 meters. The shortest distance measured for an object between initial and final points is called displacement. Okay, so initial and final point, initial point is O, final point is Q, and this distance is known as displacement. Therefore, the displacement from O to Q is, sorry, therefore the displacement from O to Q is how much? It is 40 meters. Okay, so I hope you have understood the concept. So total distance is the total path covered, total path. So for example, in this case, total path covered is 4 plus 3 equal to 7 kilometers. But displacement, what is the shortest distance between the initial and final points? That is the 5 kilometers. Okay, here also O to Q, O to R is 60 meters, R to Q is 20 meters. So 80 meters is the distance, but the displacement between O to Q is 40 meters. So that is the displacement. Okay. Now again, if the object which starts from O, okay, it starts from O to R, and then again returns back from R to O, okay. So that means O to R and R to O, total distance covered would be 120 meters. But what will be the displacement? Displacement means the object again comes back to the point O. Therefore, the displacement would be 0 because the object is at its point of origin. The object is at its point of start. So virtually the object is at its same position. Therefore, the displacement would be 0. Okay, displacement would be 0, where this 120 meters would be the distance covered by the object. Okay, so same thing has been written here. So 0 is the displacement if the object returns back to point O, but the distance would be 0 plus 60, 60 plus 60, it will be 120 meters. Okay, so finally, what can we conclude about distance and displacement? Distance may be equal to distance, but never greater. Okay, so distance may be equal to displacement, but never greater. Okay, displacement can never be greater than the distance covered by an object. So friends, I hope you have understood the concept of displacement, and in later we'll discuss displacement and distance in terms of numerical problems. So I think I will stop here for now. And if I go back to the contents, so relative motion, so up to motion along a straight line we have checked for now. Uniform and non-uniform motion we'll actually discuss in uniform and non-uniform motion, rate of motion we'll discuss in another video, so that we can keep this current video shorter. Okay, so thank you very much for your attention. I hope all the concepts have been clear to you, and see you in the next video. Thank you very much.